We're alive. Thank goodness for that. It's good to know. So we're going to look at limits of functions that contain radicals. In particular, these are usually rational radical functions that give us really bad things like 0 over 0. Okay? There's really only like a couple of things to know for this. Sometimes when you get a radical and you're taking a limit, you can actually just put the number in because it's not a problem. But sometimes when you're taking a limit that contains a radical, you get this 0 over 0 problem. And we need to deal with that before we move on to derivatives. So here's our first really super simple example. Find the limit as x approaches 0 from above of x over the square root of 2x. This causes a problem. We're going to try that thing. Let's just put in a 0 and see how it works. And if we just put in a 0, we get 0 divided by 0. And, well, we think, well, that's good. Let's just quit right there. But this is the limit. So this is the value as we approach from above of this function. And the function might not exist there, or the limit might not exist. But, sorry, the limit might not exist. But in this case, the limit from above is going to exist. So here's how we solve this problem. In this case, the simple case, we're actually just going to rationalize the denominator. In other words, we're going to find an equivalent expression that does not include a radical sign. And here's how we're going to fix it. We're going to go like this. Square root of 2x over the square root of 2x. Okay, so this is significantly less complicated than the whole, this is significantly less complicated than finding the conjugates, which you've probably done in the preamble. Okay, so the top becomes x times the square root of 2x, and the bottom becomes just 2x. Now, there's a little bit of complicatedness that I'll maybe talk about at the end of the lesson, but let's just take it from here. Now, you'll notice this happens. So this is nice. And all these problems do this, so they're kind of contrived to do that. But you will see what the purpose is. These x's cancel. Okay, so it doesn't matter how small x is. It can be getting really close to 0. As long as it's a number, they're always going to cancel the 1. So now we're ready. Let's see if we put a 0 in, if we get something that doesn't have some disturbing 0 over 0 property. And the square root of 2 times 0 is it's 0. Okay, so that's the limit. Perfectly acceptable. Turns into a 0. So this kind of problem could look like this instead. So we could have limit as x approaches 0 from above of the square root of 2x over x. Substitute 0. Oh my goodness, bad things happen. But we can probably fix it by, we can fix these ones with the radicals in the top. We can also multiply by the conjugate. This one actually doesn't exist because it goes to infinity, but yeah, it's gonna go to infinity. But you can use the same strategy. Okay, so if it's just a radical, just rationalize the denominator. Things are going to be fine. Let's go to this second one where the radicals having something added or subtracted from it. Okay, so here is our example. Once again, these all work out, so they're kind of contrived. As long as you've done the preamble, you know that we can make this a lot better by multiplying by a thing called the conjugate. Yes, okay. And the conjugate's really easy to figure out because I just look at this, and this is a minus sign. So between these two expressions, instead, I'm going to put in a
wheel of fortune
plus sign. That's right. Please ignore any crosstalk. Anyway, here we go. There we go. So multiply top and bottom by the conjugate. Now, this is magically like the difference of squares system. When I expand this, I must keep mindful that Root 4 plus x times 2 is going to cancel out with negative 2 times the root 4 plus x. So there's stuff happening in the middle, but it just doesn't matter. So I'm not going to do that. We're just going to know that it drops out. Root 4 plus x times the root of 4 plus x is 4 plus x. Stuff in the middle disappears, and this becomes a minus 4 there. And now when I multiply two rational expressions, I multiply the denominators together. Okay, so x times square root of 4 plus x. I have to put the plus sign in there, it just doesn't matter. Plus 2. And I've done the thing that you are going to do on the test. I have to make sure I write my limit in there. So all of those of you who are cursing right now because there was no limit, and now your notes are all screwed up and you got to get the white out, please accept my apologies. That's right. Okay, so 4 minus 4, that's going to disappear. Look, the x and the x are now, because I've gotten rid of my 4's, I can now cancel this out. Now I just have this really easy expression. The limit as x goes to 0 of 1 over root 4 plus x plus 2. Now I can try it out. See if I don't get that 0 over 0 that we don't like so much. 1 over the square root of 4 plus 0 is 1 over 2 plus 2. And last time I checked, 2 plus 2 was equal to 1/4. Okay, so this is how we fix taking a limit in radical form where the radical is being added or subtracted. Okay. The other case where there's just a conjugate, we can just rationalize the denominator by multiplying top and bottom by the conjugate. These can show up in the numerator or in the denominator. You just use the same strategy. That's that. 7 minutes. New record.